Hello everyone, today we're gonna solve this Boolean algebra expression. We're gonna draw the logic diagram for this Boolean algebra expression. We're gonna draw the truth table for it. Find the sum of products, this is sum of products from the truth table. Simplify using Boolean algebra rules, and then simplify it using Kmaps. Draw the logical diagram for the simplified circuit, meaning after simplification, and build it using NAND gates only. And why do we build it using NAND gates only? Why do you think it's really important to build it using NAND gates only? Because remember, we said NAND and NOR gates are universal gates. Universal, what does that mean? It's preferred to build any circuit with NAND and NOR gates, just NAND and NOR gates. They use less transistors, they're cheaper, so it simplifies the whole circuit more and more. Let's go and check. Let's first do draw the logic diagram for A or C parenthesis, now another parenthesis, AD plus AD not, this is the not, plus AC or AC or C. So let's go and check the logic diagram for this, and here we go. Let's see what we have. Move them a little bit up here. We have 6 gates. We took 6 gates. What were they? Which are the universal gates? This one is a universal gate. This is an OR, and this is another universal gate, which is an AND. This is an AND. This is an AND. This is an OR. This is an XOR, and this is an OR. I don't think we'll be using this or those. Well, I'm not gonna use this for now. I'm not gonna be using the NAND, and I'm not gonna be using the NOR. We're gonna use only oops. The complement should be here on the D. Sorry about that. So now let's see how to draw it. What do we start with? I have an OR gate here. I have A or C. So let's copy and paste. And here's an OR gate for what? You can draw here text. And here I can have A and here I can have C. This is the output. So output of this is ANDed with this. This is an AND between the two parentheses. This is an AND. It's just like saying this. This is here is another AND, but we don't put it. So we're gonna do A and D. Here's an AND. We're gonna need another one. I'm going to try to combine them all together. So we have what? A and D. We can use the same line for A, but here I'm going to use just different ones just to make it look better. And we can even use the same line for D. And just take the complement for it, and I can do the complement as a prime. Let's do it now here. So this is this, and those are this. Those two NAND gates, or they're all together. So I'm gonna take an OR mix it between those two. Here's an OR gate, which is the result of this, and I'm gonna AND this with this, those two. Let's AND it. So I need a NAND gate, copy, paste. I'll be lucky if I have space. I'm gonna do here just, okay, 1 minute. Why did it take, oh, did I take that one? Okay, 1 minute. Let's redo. Okay, I've got those. Is A, C, and I need an AND copy. Let's put it in shift. Let's try to put it here. I'm trying to save space on the let's make them smaller. And this is what I'm trying to do. Okay, now go back. And I'm gonna take a line. I can do it in curves, but here you go. You can do it this way. Make it look better. I need to change the color here to black. I can take another line from this one. Oh, let's do it. It's gonna be on the same line, and because of that I wanna change it to black and make it more thick, so we know there's a line here. Here you go. And then I'll connect it with this. Okay, so I got all of this here. Now I'm gonna do A and C ORed with C, and I'm gonna OR it with this. So I'm gonna have OR here with those, and where's is an AND. Let's make it smaller. And let's take that C with it. If I need it, I need it. Let's do it. So this is gonna give me those two. It's gonna give me this. Oh, but I need to copy this. Copy paste it here, because I took that one and I took an AND, but I don't think I need any more ANDs. And that one is going to be A and C, and we can take lines from here, but let's make them separately. Is an A, is a C, and here I'm gonna OR this with a C. And then I'm gonna OR this and that, both of those. So or I can use all of this. So I put this here, so I connect this directly, and that one I can connect directly. So here I'll have this line, another line here, and this will give me the full circuit. This will give me the full circuit here. How many gates did we use? 1, 2, 3, 4, 5, 6, 7, 8. This is D prime, or I can put it as D and add what? The NOT gate over here. So if you want, we can do it. So 1 minute, let's take the D out, bring the NOR gate, the NOT gate, make it smaller. Usually it is smaller. And here I'll add the D, or I'll take a line from here. Let's add the D. And this will give me the entire circuit. I don't know, I should have used better looking gates, but here's the circuit for this. The complement following it. So here we go, this will give us this. Now what was the second thing we need to do? Draw the truth table for this. And how do we draw the truth table? We see how many inputs do I have. How many inputs do we have? We have 3 inputs. A, C, D. A, C, and D. Don't think D prime is another input. It's the same as D. You take a line from it. So if I have 3 inputs, I have 2 to the power 3 possibilities, and I'm gonna take them from 0 to 7. And here's what I like to do. I like to do 0, 1, 2, 3, 4, 5, 6, 7. This representing what? 0, 0, 0. And this representing 0, 0, 1. And this is 2. Just convert it to binary. And here I have 3. Here I have 4. And if you know why this is 1, 2 to the power 0. This is 2 to the power 1. 2 to the power 0 plus 2 to the power 1. 2 to the power 2. And this is going to be 2 to the power 2 plus 2 to the power 0, which is going to be 5, 6, and 0, and here I'm going to have 7. Now I'm going to find D prime. D prime is 1, 0, 1, 0. I'm going to find what? The complement of D. This is D. This is D, and I found here the complement of it. And this, remember, those are all the possibilities for my 3 inputs. Now A or C. I'm going to take this ORed with this. So it's going to give me what? 0 or 0 is 0. 0 or 0, 0. 0 or 1, 1. 0 or 1, 1, 1 or 0, 1, 1 or 0, 1, 1 or 1, 1, and 1 or 1, 1. Now I'm gonna add the A, this one, with a D, and we should know the and 0 and 0 is 0, 0 and 1 is also 0, 0 and 0 is also 0, and I have here 0 and 1 is 0, and 0 and 1 is 0 also. 1 and 1 is 1. That's the only situation where I have a 1, and this is a 0, and 1 and 1 again, it's a 1. And I'll keep calculating all of this until I get to F. F representing what? This circuit, and it should look like something like this. And if you see, here's A, C, or C. What did we do? We order it with this. We order it with this. 0 or 0 is 0. 0 or 0 is 0. 1 or 1 is 1. 1 or 1 is 1. 1 or 0 is 1. 1 or 0 is 1. 1 or 1 is 1. And here 1 or 1 is 1. So now in my output, how many ones do I have? 6 ones. Those are the important for us. So the next thing was to find the sum of products. How do I find the sum of products? I'll take the 1. What's this one? It's A na C D na. So the first one is, let's draw 0 1 0, which is A prime, which is not C and D na. Now we go to the next one, and this equals A na C and D. So here I'll say 0 1 1 is gonna equal A na C and D, and this is what I mean by sum of products. Sum of products is sum of products, SOP. Now I got this, now I need to find this out. This is A C naught D naught, so this is gonna be A or A C naught D naught, which I can write it as OR, and it's gonna be A C naught D naught. Try to put them all together, group them, and now we're gonna get the fourth one, which is A C naught D. This equals A C naught and D, and I'll do space or A C naught and D. So that was the right one. Now I'll do this one, A C D naught. A C D naught. I'll write it all A C D naught. And now I'll do the last one, which is ACD. So I'm gonna have 1 2 3 1 1 1, and here I'm gonna have or ACD. Here we go. Sum of product, SOP. This is our equation for the SOP. Now let's see what do we need to do. We need to simplify, I think, using simplification rule. Simplify using Boolean algebra rule. We draw the truth table, draw logic diagram, found the sum of product, SOP. Now we simplify using Boolean algebra rules. Let's see which one of those is. I think that one. Okay. So now look at this. What can we simplify? Look at this. I can take A as common. So I'll have what? A or C, and I'll take here A as common, and I'll be left with D plus D prime, and I'm gonna put prime as a dash, not like this. Or C. Now look at this. What does this equal? D, not D. If D was 0, not D is 1. Or is 1. If D was 1, D naught was 0. So this will be 1 all the time, or true, or on, or. So what we'll have is A or C, A and 1, and I'm gonna try to do every step in detail so we don't lose anything here. Or C. Oh, why did it come small letters this one? Okay, A and 1 will depend on A. If A is 0, it will be 0. If A is 1, it's 1. So this will be A. So we'll have A or C, and I'll have A, and I'll have also ORed with A, C, or C. We have the special rule. I should have put the rules here. Here we use the factor, and we took A as a factor. And we have D plus D, or, and we're gonna use the law. I think it's the identity law. D or D naught equals 1, and we did that one here. Here we used we used A dot 1. This is the identity. That's I forgot what that one is. And this is A here. Remember the special rule we had? AC or C, what does it equal? This can say AC or C equals C. AX plus X equals A. AX plus A equals A. So now we're left with A or C ANDed with A or C. Now we can distribute. I can distribute this with this, this with this, and then we'll take care of this. So I'm gonna use the distribution law to say A or C ANDed with A, this equals AA plus AC. So now I'll have AA plus AC, and this I'll use what? The AA law, and this equals A. 1 and 1 is 1, 0 and 0 is 0. So now I'll have A plus AC, and this should simplify to A. Did we do anything wrong here? Okay, I know what we do. I'm thinking something's wrong. Can't go C we forgot to take the C. I'm only put it there. It is gonna be odd with C. So either this equals A or this equals C. Whichever one you want. Both of them are gonna give us the same answer. So now we with from that big equation with 3 inputs using how many gates? We can count the gates here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 gates to using 1 gate, which is an OR gate, A or C. So now what do we need to find out? We need to use Kmaps. I think we need to use simplify. Now simplify using Kmaps, and to simplify using Kmaps, if I got the sum of product, it's really easy, and we have the sum of product with us. So let's go to Kmaps. What do you want us to Kmap? And here's the sum of product for this one, for this table. I took out all of the ones we don't need. We need what? The result one, the F one. So let's look here. What do I have? How to build my Kmap. I have 3 inputs, so I'll have 8 rows in the truth table. So I'll have here 8 cells. Here I can say what? Here I represented CD. Here I want to represent AC. And I gave you 2 different ways to do it, so you know the difference. And actually there's not that much different. AC. Here what do we put? Here I'll have the A, not C, not, which is what? 0, 0. And remember, in Kmaps, I only can change what? One input at a time. So here I can either change the A or C prime, but I'm gonna change the C prime, make it 1, so I'm gonna have A naught and C, which equals to 0 1. Here I'm gonna have what? I'm gonna change the A because I've already changed the C, so I'm gonna have A C, which is 1 1, and here I'm gonna have, I changed the A here, I changed the C here, I'm gonna have 1 0, which is A C prime. I did try that, so that would be 1 0. What about D now? Now D, I have it here. I have D prime, which equals 0. And I have D, which equals 1. And Control A, let's put it 15, so we can. So we built the first one here. I've already built this, so we don't waste time on it. I did it using CD. Instead of AC, I used CD. CD, C naught, D naught is 0 0. C naught, D is 0 1. CD is 1 1. And same here as A. So now let's check what's the differences. So I go and look at this table. I have 0 1 0, meaning not A, C and D. Not A, C and D. I'm gonna have a 1 here representing this. It's gonna be D prime, sorry. It's good I looked at the last 0. This representing 0 1 0. 0 1 0. Now if we look to the second F that has a 1, which is the fourth row, I have what? 0 1 1, which is A prime C D. A prime C and D. So it's gonna be the one, unblur it. Now the third one is gonna be this one, which is A C A. It's gonna be A C prime D prime. A C prime D prime. 1 0 0. Now for this one, what am I gonna have? It's gonna be A C prime and D. So A C prime and D, and now I'm gonna have a 1 here. And now let's see 6 and 7. 6 is A C D prime, A C D prime, and now I have A C D, A C D. We've got this, those will be zeros, and you can see how I have 6 ones also, same as the truth table. Here to simplify, I'll start grouping on 2 to the power, meaning I can group 2 to the power 0, which is 1, 2 to the power 1, which is 2, 2 to the power 2, which is 4, and more than that I can 2 to the power 2, 2 to the power 3, 8. We might have 8 if the whole circuit was true, but I think that's really hard to get. And why are you going to use it in advance? So let's see what's going to happen in this one. Or let's simplify. We're going to take those 4. Those 4 represent what? What's common between them? A, C and C prime are not common, so I don't take. D and D prime are not common, so all of those equal A. For those 4, A. Now what about those 2? Those 2 equal, what's common between A and C? D is not common. plus A not and C. It was different from what? The last one I took. But can I change in this and make it look like that? I don't think so. It's gonna be wrong. It's gonna be A for the first one and A C prime for the second one. Zero, zero, one, zero. So let's look at this. What do I have here? CD. Now I'm gonna look at the ones. First one is gonna be C, D naught with A naught. C, D naught with A naught. So this is gonna be 1. Oh, where am I putting the ones? This is gonna be 1. Now what about the second one? It's gonna be A naught, CD, and A naught. It's this one. And now what about this one? It's gonna be A, CD, C naught, D naught. A, CD, D naught. And here's 1. And what do I have? This one. A, C naught, D. A, C naught, D is 1. And now I'm left with 2. It's gonna be A, C, D naught. A, C, D naught. This is 1. And now I can have 1, 1, 1, which is this one. And here I'll put zeros. And to simplify this, we group into 4s. So I'll have this as what? A and Control A, let's manage, plus what do I took those 4. I'm left with this. What's common between them? It's the A naught and C. A naught and C, and it gave us the same result. This is our simplified circuit. And now let's see, what do I need to do more? Simplify Kmaps, we did it. Draw the logic diagram for the simplified circuit. That's gonna be easy. Build it using NAND gates. Let's draw the logic diagram for the simplified circuit using Kmaps. A, control copy, and just waiting here. Let's see what you have. A naught and C. So I'm gonna have A naught. I can put it as a prime, or I can put the NAND gate. But let me bring the NAND gate out here and use it. Where's the NAND gate? This one. Am I gonna use it anywhere else now? So I can take it. I have other gates. I was just preparing those just to make it faster. Here's a NAND and a NOT gate with a NAND, with ANDed with C, and then ORed with which one is OR? Who remembers this one? No. NOR. This one, no. XOR. This is and what do we do here? We take, or I can use it because I don't have any. But here I have a problem. This is a NAND. So go home and you come here. I need the AND. see this OR with the C, A, and let's take this. And what do I need to OR it with? OR it with an A. What's this? This is represented using this one, the and not, and this is represented using A or AC prime, and here I have A as another input, or I can take it from here, but I prefer to make the picture look better, the graph. Just draw it by yourself, and be careful when you do that. Check how many time you left with before you start doing it. Shift C. Okay, that took it. Let me just put a new one. There was just a line that came out and I had to take it. And here I'm gonna have C. This is the new circuit. I used their 9. Here I'm using 3. I'm not sure how the simplification rules gave us a shorter circuit. Maybe I done a mistake, but I'll go over it and check it. Now the Kmaps will give us the minimal solution, the best solution. And everybody is asking about it. I'm thinking of downloading a video in a minute on it. So I'll let you know. And what do I need also? Where's Dr. Moore? And now I need to do this circuit in NAND gates. What do I have? I'm going to take this one. I'm not going to take the one I simplified using the rules. Control copy. And how can I change it to just NAND gates? And to do this just in NAND gates. And I'm going to do it here so we can check. I'll have what? 2's complement. Let's put 2's not 2's complement. 2 complements. This is 1, meaning 2 knots. Not 0 is a 1. And if I knot it again, it's back to 0. So this won't change the equation. So what will happen? I'll apply De Morgan on the first knot, meaning on this one here. I'm gonna apply De Morgan. What does De Morgan say? Distribute the complement and change the sign. So I have and A not C. I distributed this complement, which is in the middle, so I don't need to distribute this one. So I'll take it and I'll use it. Control V, and this is what's an AND gate. This was easy. We didn't do that much work on it, but let's see if I have A plus C. Where did it change? D went left, so oh, I can't focus. And so here's the NAND gate for the same circuit for this one. And why did we say NAND gates? Universal gate, because a NAND gate is a universal gate. What other universal gates do we have? The NOR gate. And why do we do that? It's cheaper. NAND gates are cheaper and you use less number of transistors. And I have to keep the complement with me wherever I go, because the complement makes it an AND. It's an AND, but the complement makes it an AND. And you don't need to worry about going inside and doing the same thing for A and C. Okay, I think here we're done. Thank you guys, good luck tomorrow, and see you all.